right, folks, you need your HBS course file. We have a little bit of notes that we need to finish adding in there. So this has been a big chunk of notes that we have taken. That's stupid. But this is kind of setting us up for next week. So next week are tours, and I'll talk to you a little bit more about tours here in just a second. There will be days where you're working in Mrs. Newman's class, getting stuff done for Biomed. There'll be days that you're in here helping us run the tours. And like I said, I'll explain that more in just a minute. But the notes that we've taken over the skeletal system and 1, 2, 3, which is forensic anthropology, that gets you set up for the next few things that you're going to be doing when you're working in Mrs. Newman's room next week. Okay, so skeletal system, we talked about the types of bones, we talked about bone cells, we talked about the different parts of a bone, we did our feedback loop for calcium. Does that all sound familiar? Okay. Then the next thing has to do with the two pictures I gave you. So the two pictures I gave you, one represents compact bone, one represents spongy bone. Do you remember what tissue type compact bone and spongy bone are? Which of the 4 types of tissue? Connective tissue. All right, so we're going to look at different aspects of each one of these different tissue types. So before you copy anything down, remember, our goal for second semester is to kind of give ourselves some notes that are a little bit easier to see. So don't write anything down yet. Let me just give you the overall view of how I've done this. So I've divided both of these pages in half, and everything up here on the top represents, it's on that chair right there, if you would. But yes, if you would, please. Thank you. All of this on the top represents compact bone, and so that's why I have this diagram here, and I've got the diagram taped in so that I can get to this information that's under it, and you'll notice that I've also put stuff on the diagram. We'll get to that. Everything on the bottom is spongy bone, so compact bone, spongy bone makes it really easy for me to find. Notice that I've got space in between so that I don't have stuff that's just a big chunk together and I have to read through everything to find stuff. I would also kind of recommend, color. I always love color and highlighting, so any terms that you feel that you need to stand out, then you highlight them. And remember yesterday I talked about the fact that there are times where, I know I will struggle with pronunciation of stuff, so this is my pronunciation key. I ain't got no grammar skills, so I have no idea if that's right or not. That's just when I look at, I know that this word is pronounced canaliculi. So that tells canaliculi. So that tells me how to pronounce that term. So you put down whatever works for you. Same thing for any of the other abbreviations. Okay? So I'm going to get started. We're going to start on the right-hand side of this page, and I wouldn't necessarily tape that picture in just yet because we are going to label stuff on there. I would recommend highlighters because there's a couple things that we need to highlight on that so that it stands out. All right, so this is compact bone. Compact bone is the harder bone. On our bone diagram, it was kind of on the outside edge of that bone. Components of compact bone, first of all, is the osteon. Notice that I've got this whole, bless you. Notice I've got this whole circular structure bracketed. I labeled that number 1 so I can come back and see number 1 and kind of quiz myself. And so that's the osteon. The osteon, on that diagram it looked kind of cylindrical. It is the functional unit of compact bone. So compact bone is made up of osteons. Osteon is a cylindrical structure. It is the functional unit of compact bone. So on the diagram, I bracketed so that I had this whole cylindrical unit. So this is an osteon, this is an osteon, this looks like a big old osteon, osteon, big old osteon over there. Pardon? I bracketed this whole cylindrical structural unit because that represents number 1, which is the osteon. This is an osteon, 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 absolutely. This is compact bone, and in compact bone, that's how the functional units look. I hesitate to agree with that really broad statement because probably. It's kind of like ACE tells me it's an enzyme, but not all enzymes end in ACE. So I'm going to say, for us, yes. Now, if you go into that, they'll probably say, well, that's all a lie because blah, blah, blah. But, you know, for us, we're just learning fundamentals. All right, so osteocyte. Cyte means cell. Erythrocyte, leukocyte, osteocyte. Osteo is telling us that this is a bone cell. So I highlighted that yellow so that I can come back to my diagram and I can see that these are my little osteocytes. So these little freckle-looking things, those are osteocytes, so I've highlighted a few of them yellow, so I know that's what it corresponds to on my notes. So osteocytes are bone cells. Next, let's just do this part first. Next is the Haversian canal. Haversian canal is a canal. It is a channel where blood vessels and nerves are going to run through that compact bone, because compact bone is the really hard part. But a bone is not non-living. It is a living organ of the skeletal system. So it's got blood vessels that nourish it, pick up waste products. It's got nerves to pick up stimuli and send information. So Haversian canal. So when I labeled it, just ignore that. That's just a smudgy, messed up part. I gave myself this right here to tell me this is how I'm labeling Haversian canal. So the big, dark, solid black pits that are on there, I highlighted that because that represents the Haversian canal. So that's a Haversian canal, Haversian canal, Haversian canal, Haversian canal. All right, so next is canaliculi. So the canaliculi are gap junctions. So before we listen to my melodious voice for just a second. So remember, compact bone is the solid part of bone. It's hard. That matrix is made up of really tough minerals and fibers. But bone is not non-living. It's a living thing. So the cells, the osteocytes that are the little specks, the yellow specks that we highlighted on there, and they're embedded within there, those things need nutrients. They need stuff to come in. They need to get rid of waste products and get rid of the stuff that they're producing. So we need a way to do that. So within that compact bone, there are these little bitty tiny holes, tiny pores, if you will. They're gap junctions, so they're junctions between cells. But essentially it works like little tiny holes or tiny pores, and that's where it's going to allow nutrients to pass and molecules to be swapped out between those osteocytes, between those bone cells. So canaliculi are little gap junctions, little holes, if you will. It allows that transfer, nutrients, molecules, the stuff that those osteocytes need and need to get rid of. It gives a way for it to, gives it a path. So the canaliculi are really hard to see, so I had to help myself out a little bit by kind of emphasizing, if you will. So I drew some little squiggly lines on my diagram to help me see essentially where they would be at. Now the canaliculi are on there. They would just be really hard to see. Little squiggly lines. So on my diagram, number 4 is right here, and those are my little squiggly lines to represent my canaliculi. So those are basically the structures of compact bone, and then we'll come back and we'll do that for spongy bone. So now it might be a good time to take that on the top so that you can see all that information. All right, so I'm moving to the left. I'm going to go on that left-hand side page. And keep in mind everything across the top goes with compact bone. So these are all the features of that bone itself, and now we'll talk a little bit about, its makeup, its composition. So this is still compact bone. Compact bone is a matrix of mineral salts and protein fibers. So the mineral salts are calcium and phosphorus, essentially, and the protein fibers are collagen. Compact bone is made up of a matrix of mineral salts like calcium and phosphorus and protein fibers like collagen. Each of those components have a specific purpose. So mineral salts, those are really hard substances. And so they give bone its strength in terms of it's very resistant to compression or to squeezing forces. So mineral salts, they help the bone to withstand squeezing forces. Salts are very hard. I mean, think of it like table salt. That's hard stuff. It's not squishy. So the mineral salts that are part of the compact bones matrix give it strength to be able to withstand compression or squeezing pressures. The protein fibers, the collagen, give it a little bit of flexibility, if you will. That's really good. They can withstand lots of tensile pressure. So tensile forces are stretching forces. So you can kind of think of it a little bit like maybe the cartilage on the top of your nose, maybe. I mean, it can withstand a little bit of that stretching force. So collagen fibers have great tensile strength. Tensile means that stretching force. So the mineral salts help it to withstand compression. Collagen fibers help it to withstand the tensile forces, the stretching forces. Have great tensile strength. Oopsies. So the osteocytes that we labeled, that we highlighted yellow, remember they're within that compact bone, they're within that matrix, and so they have these tiny spaces called lacunae where the osteocytes are located. Canaliculi are the channels, if you will. Lacunae are like the little spot, the little tiny spaces that the osteocytes are in. It's the spots within the matrix. Spaces within the matrix. Next, I'm just going to go right below that. Remember, I've got a nice big line that separates my compact bone and spongy bone. So this is going to be spongy bone information, and we'll talk a little bit about its structure first. So spongy bone is very porous. Compact bone doesn't have a lot of spaces, just small lacunae right there where the osteocytes are at. Spongy bone has a lot more space in between it. The lattice that makes it up, that makes up its matrix, has a lot more space. Spongy bone has lots of vascular tissue, blood vessels, cardiovascular, cardio, heart, vascular blood vessels. Spongy bone has lots of vascular tissue. So the matrix of spongy bone is more lattice-like. It's not as compact. And so that matrix, that lattice-like matrix, has little columns or plates of bone. Those columns or plates of bone are called trabeculae. Lacunae were the bitty spaces for osteocytes. Trabeculae are the plates of bone in spongy bone. So lattice-like matrix of thin columns or plates of bone, trabeculae. So spongy bone also has the lacunae. It also has those spaces, cavities. Oh, that's a better word, cavities. All right, so another word that I threw on here, and I can't remember if I've seen it on tests or seen it somewhere, but I just really like it anyway. So our bones, one of the functions of our bones is to create blood cells. And as it turns out, blood cells are created within the spongy bone. So erythropoiesis, that is the production of red blood cells, the production of erythrocytes. So erythropoiesis, erythrocytes. And I can't remember the context in which I've seen that term, so I just kind of threw it in there. Come across it again. So erythropoiesis is a process. It's the production of red blood cells, which makes sense because red blood cells are erythrocytes. All right, so on this side right here, on the back of the picture, spongy bone is found in the medullary cavity of the long bones. Spongy bone is found in the medullary cavity of the long bones. Spongy bone is found in the medullary cavity of the long bones. Spongy bones also found in the flat bones, like for the hip, the sternum, the ribs, and the epiphyseal, the ends of long bone. Spongy bone found in the medullary cavity of long bones. It's also found in the hip bones, or in the flat bones like hip, sternum, ribs, and the epiphyseal ends of the long bones. Epiphyseal ends of long bones. Yep. All right. Two types of spongy bone, yellow and red, and each basically have a different function. But these guys are made up of stem cells. Have you heard of stem cells before? Does that sound familiar? If you've heard of stem cells before, you might have heard it in terms of the fact that these kind of cells are like the originator cells. So stem cells, depending on what influence is placed on them, can turn into basically any type of cell. So some stem cells are a little bit more talented at doing that than others. The stem cells that are part of our spongy bone, they are going to make multiple types of cells depending on the influence, whatever hormones put on them, whatever they're supposed to make. But they're limited. We're going to limit it to 3 different types of cells for each type of bone marrow. So yellow bone marrow, yellow marrow is spongy bone, and yellow marrow has mesenchymal stem cells. Yellow marrow has mesenchymal stem cells. Yellow marrow has mesenchymal stem cells. So mesenchymal stem cells are a type of stem cell that can create fat cells, cartilage cells, or bone cells. So within yellow marrow, we have mesenchymal stem cells, and those stem cells can create fat, can create cartilage, can create bone. So your yellow marrow is responsible for creating fat cells, cartilage cells, bone cells. Our red bone marrow contains hematopoietic stem cells. Your hematopoietic stem cells are the ones that are responsible for your erythrocytes, leukocytes, thrombocytes.